Yo, what up, guys? We're gonna be covering a brand new lesson to start off our new unit. Some of it's review, some of it is, or I should say the majority of it is brand new content, but it's not gonna be hard. It's more of the more exposure, the more you work with these types of terms, things will become a lot easier, okay? So to start off, we're gonna talk about parallel lines, because that's pretty much going to be the majority of our unit, parallel lines and angle relationships. But I'll ease you guys into it. It's going to look daunting sometimes. It's going to look like there's so much in terms of content on here, but the minute you pick up on how to go ahead and use these terms to the figures, how to break down the words contextually, it'll make things a lot easier for you to understand. Alright, so let's start off with parallel lines. You're probably wondering, where am I getting this? It is on the timeline, so these are your notes. So you're gonna watch the video and then fill in these notes, and then we'll get more practice with the terminology later on. But let's start off with talking about parallel lines. Now, you're still used to saying that parallel lines are two lines that never intersect and they go in the same direction, which is true, but just to be a little bit more specific, right? That they're gonna be two coplanar lines that never intersect. Okay, so they lie on the same plane. Hence, like if I were to go ahead and take this piece of paper right over here, and I were to go ahead and lay two pens like this, they are the same plane. They're not intersecting, and they're going in the same direction. Right? Now, we need to go ahead and talk about how do we look at a figure and determine the parallel lines. It's very simple just to say, oh, my hands are parallel because they look like they're going in the same direction because they're never touching, right? But in this case, if you look at the figure to the right, I have line AB and line CD. I know they have arrows on the right side and on the left side, but this is darker arrow that's on the figure, like literally like smack dab right near in the middle of it. So these two arrows will tell you if they're parallel. If those two arrows didn't exist, then you can't assume that the lines are going to be parallel. So arrows are used to indicate that the lines are parallel to each other. And of course, there's going to be a symbol to this, right? The symbolic notation is just basically two slashes going up and down. I kind of lean it to the right a little bit, right? Going up and down. So in this case, I can say that line AB is parallel to line CD. Alright, so those two are parallel, not because I'm telling you, it's because they have the arrow notation right on here. Okay, now we gotta talk about parallel planes. Just think of two pieces of paper that are just never intersecting and they are going in the same direction, right? So parallel planes are planes that never intersect. Right? Planes that never intersect. Right? So if I was going to use a symbolic notation, I would say plane. Right? And since they give you like a little cursive letter on the very top, in unit 1 we said, well, there's a cursive letter on the very top, right? Then that way we could say that plane J, right, is parallel to plane J. Simple as that. The next term is weird, right? Skew lines, because how I describe it can almost be, confused with the term parallel lines, right? Skew lines are basically non-coplanar lines that never intersect. And they're like, oh, students would be like, yo, Hoyne, you said they don't intersect, so they must mean that they're parallel. I'm like, no, not necessarily. Because there's several ways lines cannot intersect and not go in the same direction, right? So I got parallel lines right over here, right? Hopefully you guys can see in the right corner as I'm describing all this stuff, right? These are parallel, right? They never intersect, they go in the same direction. But here's the thing. If I were to go ahead and just rotate this pen, basically if you guys could see it, right? I'm rotating this pen. This one's going up and down, right? And this one's kind of heading towards my face. They're never going to intersect. They're on different invisible planes, as you would say, right? They never intersect, right? And they go in different directions. Again, this red pen basically going towards me, and this little stylus pen is going up and down. So those would be examples of skew lines. Now, looking at this figure, we can come up with a bunch of examples. I'm going to keep it narrowed down for you guys to understand. Let's say I have TU. So this is TU, right? So I'm going to find a segment that is skewed to TU. I could say TU is skewed to PS because while TU is going this way, PS is kind of going towards me, right? So PS and TU are skewed, right? I could say UV, let's say let's go UV, same thing, this is going this way, right? I could say it's skewed to SR. Alright, it's skewed to SR. And then the next one would be TP. Let's try TP. TP, when I'm going up and down, TP, right, is skewed to QR because there's one going up and down and one basically going towards you, so QR. Now, I know I listed 3 examples. There are many more, but it's just going to be a bunch. And I think you'll get the point, right? So those are examples of skew lines. So let's do example 1 together, right? So example 1, it says name all the segments parallel to AE. Remember, they're going in the same direction. So I have AE basically going up and down. So we need to find other segments on this rectangular prism that's going up and down. So I have HD, GC, and FB. So HD, right, GC, and FB. Then they say, give me 2 examples of parallel planes. Now this is going to be a little bit different because if you know over here we were naming planes with 1 letter, but now we don't have any fancy letters over here. So just to recap, when you're naming a plane, if they don't give you like a little fancy letter in there, you can name it with any 3 points, right? Any 3 points that are non-collinear, right? So basically random points. So let's go ahead and talk about 1 plane. Keep it simple, right? I'm going to talk about this front plane. So this very front plane. So I have, it's like a rectangular figure, AEFBE, right? So when you're naming a plane, you can use just 3 letters. So I can go A, E, F. Now, I'm going to get a little fancy on me. You can just go A, B, F, or F, A, B, whatever it is. So any 3 letters, right, that make up on that rectangular base. So I can say plane. Okay, let's go AEH. Not AEH, AEF, since we're talking in French, right? AEF. Right? Now, the plane that's parallel to the very front of this would be this back one right over here. So I'll choose any other 3 letters. So I can say plane HDC. Right? HDC. Right? Let's do another one. Let's talk about something else other than front and back. Let's choose the left and the right side. So my left side right over here, right? I got AEH, right? Plane AEH. That's the left side, right? And on the right side, I would choose one of these, so I can say plane, and any one. I'm not having any preference towards the letter, so I can just say FCB, right? Any 3 letters that make up that side, right? Alright, last one, right? It says name all the segments that are skewed to segment GH. So let's hunt for GH. So GH is this back piece right over here, right? GH is his back piece right over here. So when you're doing this back piece, we got to figure out all the pieces that are not going to be touching or going in the same direction. So the 2 easy ones would be, well, I have FB and EA because those are in the front, and this one's going side left to right. So I can go ahead and say segment EA and segment FB. Now, what are the other ones? Well, what's common is that people are like, okay, well, GH is in the back, let's go with GF. Well, we can't do that because they intersect at this corner. But if I go to these bottom pieces, right, if I'm focusing on GH or HG, right, CB and DA, they don't connect, so I can go ahead and say CB and DA are also skewed to it. So, there you go. What I want you guys to do is this, right? I want you guys to go ahead and pause the video, and we'll do example 2. And when you come back and I unpause the video, magically the answers will pop up. Alright, so pause the video and then check your answers and my explanation in it. Boom! Alright, just popped up right there. All these answers are available for you guys. Keep in mind that the ones that says all, they're kind of non-negotiable. Like for actually A and B, they're non-negotiable. These are all the answers to it. But if you wrote it the other way around, saying PO, OJ, PK, LQ, MR, that would be fine. For letter C, if it says name a plane parallel to JKL, well, JKL is this very front pentagon right here. So the plane that's parallel to it would be the back one. I chose SOP, right? But again, you can choose any 3 points. Like you could have said SRQ, SRP, QOS, any 3 letters that make up this plane, right? And then name 4 segments that are skewed to RQ. So RQ would be right here. So you just pick, things that are not going to be on the same plane, like JO, right, would be a good one. JK would be another good one. Just as long as you understand, like if you were to extend this line out, that it can never hit the corner of it, okay? So like sometimes you gotta extend some of the sides out, right? So, cool, got the first page down. Now, I did tell you guys that there's some parts of the lesson that's gonna be a little bit intimidating, but not really, right? You guys gotta trust me on this, right? So, the meat and potatoes of not just this lesson, but this unit is going to be talking about this term, transversal, and talking about angle relationships formed by a transversal. So, that's why I created this video. That way you can go ahead and rewind multiple times and, try to get an idea of what I'm trying to pick up, just not in one swoop and just not on a piece of paper, but you have a video explaining forever what this stuff is. Now, a transversal, right, is a line that cuts through 2 or more lines. So, for example, on this figure, I have line L and M, right? They're going to intersect, but that's besides the point. What they share in common is that they have a line T that cuts through each of these right over here. Cuts through this point and this point, right? So if they ask you, yo, what's the transversal of this figure? It's simple. You would just say line T. Line T would be the transversal. But what's the crazy part is that when a transversal cuts through 2 or more lines, all these crazy angle relationships start to form. Okay, all these crazy angle relationships start to form. Alright, so I'm going to do some highlighting, some notes, because I'm not going to lie. I would not want you guys to memorize this, right? There's some tricks to it that I want you guys to just, remember, right? Some words that you want to focus on, right? So I might use my handy dandy, highlighter over here. Alright, so in this case, when I'm talking about corresponding angles, it says angles they're on the same side of the transversal and in the same position, right? So some things I will highlight is like the word same position, right? And then just watch how I explain what I'm talking about, okay? So I have, if I cover this up here, line L and T, they intersect. They create angles 1, 2, 3, and 4, right? We do the same thing. If I cover this up, I have line M. It creates 5, 6, 7, and 8, right? What I'm talking about with same position is if I cover this up, now I want you guys to look at angle 1, right? If I just look at these 4 angles, angle 1 is on the top left corner, right? If I cover this then, right, what's on the top left corner? Angle 5. So I can see that because angle 1 and angle 5, they're on the top left corner, right? They're going to be corresponding with each other. So angle 1 and angle 5, right? These are going to be super quick to do, right? Now, next one is that I have angle 2. Well, angle 2 is on the top right corner, so is angle 6. So I can say angle 2 and angle 6. Right? 4, bottom left corner. 8, bottom left corner, so I'll have angle 4 and angle 8. And the last one, angle 3, bottom right, angle 7, bottom right, so angle 3 and angle 7. It's that easy. So corresponding angles are in the same position, right? Now, this is the way it's a little bit trickier, but if you guys just seriously take my clues, it makes things a lot easier, right? So I have the next term is alternate interior angles, right? Interior, right? Interior, this little note means inside, right? Inside. And when I say the word alternate, that's going to mean diagonal. right? The diagonal from each other, right? So interior means inside, alternate means diagonal. Now, you're saying, again, what do you mean? How does this relate to the figure, okay? So if I go ahead and look at alternate interior angles, I have L and M. I have angles outside of L, 1 and 2 are outside, 8 and 7 are outside as well, but I have a group that's sandwiched, right? Think of the word sandwiched, right? Anything, all that good stuff in the middle of a burger, right? 4, 3, 5, and 6. Those are interior angles, okay? So we have 3, 4, 5, and 6 that are interior angles. But then I give you a clue of alternate interior angle. So where alternate means diagonal. So if I go ahead and just look at 4, right? That's inside. What's diagonal and also inside of it? Which is 6. So this would be angle 4 and angle 6. Other one would be 3. 3 is inside and it's diagonal of 5, which is also inside. So that's going to be angle 3 and angle 5. Alright? Now, alternate exterior, it's the same idea, but exterior, right, means outside. Right? Means outside. And so, if I look at 1, well, that's outside. And what's diagonal to it? 7, which is also outside. So, angle 1 and angle 7. 2 is on the outside. What's diagonal to it? Would be 8. So, it'll be angle 2 and angle 8. That's simple. On the flip side, right, we have this crazy word, consecutive same-side interior angles. But again, interior and exterior, boom, boom, we know. But in this class, I don't really use consecutive much. Sometimes when I give you an assignment, it says consecutive. But what I want you guys to focus on is the word same-side. Same-side gives everything away, right? So if I go ahead and say, well, which are same-side interior angles? I would say in this case, well, 4, what's on the same side but also inside? 5. So angle 4 and angle 5. Alright? If I look at 3, what's on the same side of it? It'll be 6. So then you have angle 3 and angle 6. Exterior is exactly the same thing. I have 1, right? What's on the same side of it? 8. So 1 and 8 would be same side exterior. And then the last one would be 2. And what's on the same side of it? 7. So I have angle 2 and angle 7. Alright, so I gave you guys a bunch of examples. We're going to work on some of these right now. So I'm going to try to go ahead, pop this up. There you go. Alright, excuse the sun on there. Try to close as much of the blinds as I can, but couldn't cover up this part. But anyways, we're going to use this to help create relationships. So I'm going to do 3, and I'm going to give you guys a chance to do 4. So here you go. This says name the angle relationship, which is one of these 5 up here. You're allowed to say no relationship exists, right? If there are none, right? Oh, right, none. There's no relationships that exist. So very first one. Let's start with 1 and 8. So 1 and 8, if I look right over here, they're on the outside of the lines, right? They're outside. Now that's sandwich, right? So that's an exterior one. And so since they're exterior and they're diagonal from each other, this would be alternate exterior. Okay, notice I'm shorthanding it. Okay, so that way it's less right. Now let's look at 2 and 3. Well, 2 and 3, they're sandwiched in between the 2 lines. Because they're sandwiched in between the 2 lines, it's going to be interior. And note that they're on the same side of the transversal. So this is going to be same side interior. 5 and 7, right? Let's look at this. 5, that's exterior, 7's interior, so we can't use one of the first 4. But I do know that 5 is on the bottom left corner, right? Bottom left corner right over here. And then 7 is also on the bottom left corner, so this is going to be corresponding angles because they lie in the same position. Alright, corresponding. Let's look at 2 and 7. 2 and 7, right? 2 and 7, they're sandwiched in between, so that's an interior. And since they're diagonal, that would be alternate. So that would be alternate interior. Alright, 1 and 3, let's look at 1 and 3. That's exterior, that's interior, so we can't use the first 4. I do know that 1, that's on the top left corner, and right, top left corner, we cover this up, that's top left corner, 1 is on top left corner. And 3, that's also on the top left corner, so that's going to go ahead and be corresponding. So they're going to repeat. And then 5 and 8. Look at 5 and 8. Alright? They're both exterior and they're on the same side of the transversal R. So that would be same side, exterior. Same side, exterior. Alright, here you go. This one's a harder one. But what I want you guys to do is pause the video. Right? Pause the video. And when you unpause it, you're going to go ahead and have all the answers ready for you. So, okay, get ready to pause. Boom! Answers popped over here. Alright, so here are your answers for A through J. I want to talk about the nuns, right? Those are the ones where people get confused, right? So I want you to look at 6 and 11, right? So I have 6 over here, and I have 11. What some people will tell me is, oh, those look like they're alternate exterior. But here's the thing. This angle lies all the way over here. 11's not even on the same transversal as B, right? And then 11 is on the same transversal as A. Since they don't have the same transversal, they can't be classified as any angle relationship, right? And then let's look at 4 and 13. 4 and 13, I have 4 right over here. If I look over here, cover this side, 4 right here. That's on the transversal A, right? And then 13 is on transversal B. So you can't say that they have any relationship because they don't lie in the same transversal. So in order for you to go ahead and establish an angle relationship, it needs to be on the same transversal. Alright? So your homework is basically, what we just talked about today. I hope this helps out very much. I highly recommend that you guys watch the video again to fill in any missing, parts. But yeah, it's if you get this lesson, you found it easy, then you're on pretty good shape for the rest of the unit. Okay, so make sure you guys know these terms. Okay, highly recommend that if you want, start building your cheat sheet for unit 3. All right, take care, guys. Have a good one.